All right. Hi, this is Coach Bright. I'm just writing this video, or I should say recording this video to help anybody to be able to classify triangles. Classifying triangles. In this video, the knowledge that we needed was the converse of the Pythagorean theorem. If we recall, the original Pythagorean theorem states that when you have a right triangle, namely right triangle here, we call this C, go A, B, and this be C, so that this figure side is here, C, opposite of here is B, opposite of here is A. So when we use the Pythagorean theorem, abbreviated mean is A squared plus B squared equal C squared. Okay. And C being across from the right angle, it being the hypotenuse. It's the hypotenuse and the longest side. You can also write this as C squared equals A squared plus B squared. Of course, this is commutative, so you could switch it around. Now, we come up with the converse of the Pythagorean theorem, which states that if you have C squared equals A squared plus B squared, then you do have a right triangle. Basically, we're going the other way around. The Pythagorean theorem states that if you got a right triangle, it's a right triangle, and that A squared plus B squared equals C squared. The converse of the Pythagorean theorem goes the other way around. Stating that because you have that relation, because you have C squared equals A squared plus B squared, or A squared plus B squared equals C squared, then you have a right angle. So therefore we could determine that we have a right angle, that this is a right triangle. Not only a right angle is a right triangle if you have C squared equals A squared plus B squared. So when we want to classify triangles, the first case, that will be the first case. If we got a relationship, C squared equals A squared plus B squared, okay, then it is a right triangle. If we put in the numbers and all these problems that you get when you're classifying, you'll be looking at three sides. You put the longest side first, and then you check. So before I go and put an example, I'm going to show you how you can also determine if it's a acute triangle. Well, if you have C squared plugged in, and this less than the other two sides, A squared plus B squared, then it will be a acute triangle. Furthermore, if you put the sides in and you have C squared is greater than A squared plus B squared, then you have an obtuse triangle. Okay, so I'm going to use a couple examples so you can see. All right, so I'm going to erase this off and use this. You know what? Okay. All right. So let's look at an example. So the problem will be as follows. State if each triangle is acute, obtuse, or right. And again, I'll put it on this document, on this page, I should say. If you have c squared equals a squared plus b squared, it is right. I'm just going to abbreviate right triangles. If you have c squared is less than a squared plus b squared, then you have acute triangle. And then if you have c squared is greater than a squared plus b squared, then you have obtuse triangle. So those are the cases that we're looking for. So when we get a problem, so it'll be our example, get a problem, have a triangle, okay? And it's definitely not draw to scale. Okay, none of these triangles will be draw to scale. All right. So you will look and you'll locate, the first thing you want to do is locate the largest side and plug it in. And then plug in the other two. So the largest side in this one will be 13. We plug that in for C. The largest side is always C. No matter if it's a right angle or not, it's always C. Then we plug in the other two. We plug in the other two, we get 5, and we're going to square it. We get 12, and we're going to square it. It doesn't even matter where I plug those two in at. So 13 squared is 169. 5 squared, 5 times 5 is 25. And 12 squared is 12 times 12 is 144. Namely, you go and we add these two up together. And we get 169. Okay. So this one is 169 equals 169, then this is a right triangle. This is a right triangle. Let's do another one. Let's do another one. To suppose we have, let's do another triangle. Suppose it's 5 here, 10 here, and 13 here. Okay, same steps apply. You take the largest one, you square it, and I should have actually, be honest with you, when you're doing this, we don't know if it's going to equal. So it's really a question mark there. It's a question mark, whether it equals, okay? There's a question mark. We don't know if it equals or not. okay? We don't know if it's equal or it's not. We don't know. So we plug it in, and we got 5 squared plus 10 squared, okay? So we're going to see if this equals, so again, 13 squared is 169. 5 squared is 25. And 10 squared is 100. Then we get, add these two up together, you get 125. Bring this 169 down, and it is greater than 125. Since it's greater than, it works out to be obtuse. So we plug in obtuse. We say obtuse. This is an obtuse triangle. So the steps will always be the same. We take in the numbers of the largest side, leave it as C. Then we plug in the other two. It doesn't even matter where we plug them in at. We plug in the other two sides. And if we plug in the other two sides, and after we do the math, the multiplication, then the adding together, then we can determine whether it's greater than or less than. If C squared side is greater than the other two, the longest side is greater than the other two, then it's obtuse. If it's equal to, it's right. And if it's less than, it's acute. So I'm gonna go ahead and stop recording, and I hope this helps.